the shortest distance from a line to a point. So like it says in this lesson, we're going to talk about how to find the shortest distance between a line and a point. When the shortest distance between a line and any point is a perpendicular line. That's it. That's the answer, right? So if I'm trying to find the closest distance from this line here to that point right there, it's going to be a perpendicular line. Hopefully not as squiggly as my line. So what we got to do here is find a point right there that's going to be perpendicular to that point P. That's kind of the goal here. And the way we're going to do that is just we're going to make a point here, and we're going to call that point XY. And what we know about this line here and this line right here is that if they're perpendicular, the dot product should equal 0. So if you find a vector equation right here and a vector equation right here, the dot product of those two vector equations should equal 0. That's going to kind of be what we're going to do with this. So line has a vector equation of this, where t equals r. Let p be the point 5, 1, 5, negative 1. Find exactly the shortest distance from the point P to the line. So again, all we have is a vector equation going this way. We have a point P somewhere, which is 5, negative 1. I'm going to try to find the shortest distance, which we all know is going to be perpendicular. So I just got to try to find the perpendicular here. So the way we set up is like this. So I'm going to name this point right here. I'm going to call it, let's say, Q. And what's going to happen, so we're going to have this vector PQ. This vector going this way. And I'm going to dot it with the direction, the angle, this vector going this way. Remember, and this is a vector going that way. This line is this guy. Remember what we only care about, though, is the direction vector. So this guy is the vector I'm going to care about. That's it. So I'm going to dot the direction vector of this line with the angle with this vector right here. To do that, I got to find Q. So this to recap, we're going to do the direction vector times my vector PQ. So first, let's talk about what is Q. Well, Q is any point, any point on this line. So Q is really just this equation, right? Where it's just whatever value of t works. So Q is actually just the vector 1 plus 3t, p plus negative t. That's all Q is. It's some point on this line. This is exactly what this thing stands for. This is some point on that vector equation. That's all it is. So Q just can represent this. What if I want PQ? How do I do PQ? Well, like we always do. Q minus tip minus tail. Q minus P. Q is this. Minus P, which is 5, negative 1. So we're going to get 1 plus 3t minus 5. Also known as 3t minus 4. And I'm going to get 2 minus t minus negative 1, which is just a positive 1. So 3 minus t. So this right here is PQ. Right, so let me go over that again, right? You're trying to find the shortest distance between this line and that point. So what you got to do is, well, in this case of the line, all you really care about is the direction vector. It lets you know which direction the line's going. For this guy, I gotta find a vector equation. So you have your point P. You gotta make a point over here. I just made a point Q. So how do you find that point of Q? Well, Q represents any point on this line. That's what the vector equation is all about. So use the whole vector equation to be your Q, and then you do what you normally do. PQ is just tip minus tail. So I got this. Now, since it's perpendicular, the dot product should equal 0. So my direction vector 3, negative 1 dot my PQ 3t minus 4, 3 minus t should equal 0. And the way the dot product works, you just multiply the top row, multiply the corresponding parts, add it with the other corresponding parts, and it should equal 0. So I get 9t minus 12 plus negative 3 plus t equals 0. Add like terms. So I get 10t minus 15 equals 0. So 10t equals 15. So t equals 15 over 10. Or if you prefer, 3/2. But the thing is, that's not a distance. 3/2 is like the time it takes for you to hit the shortest distance. So that's how long we've been going on this path to get to the shortest distance. What's the actual shortest distance? Well, the shortest distance would be the magnitude of PQ would be the shortest distance. So what is PQ? It's this guy, but now we know what T is, 3/2. So let's plug it in. 3 times 3/2 minus 4 3 minus 3 halves. Oh, hope we like fractions. Let's see. 9 over 2 minus 4. It's a common denominator. 2 over 2. On the bottom, I have 3 over 1 minus 3 halves for common denominator. 2 over 2. So I'm going to get, let's see, 8. So 1 half, 6, 3 halves. So that's actual PQ. Like the actual coordinates for PQ are 1 half and 3 halves. But again, I want the distance. So magnitude. So that's going to be first term squared plus second term squared. So I'm going to get 1/4 plus 9/4, 10 over 4, or rad 10 over 2. That's actually the shortest distance, right? Because it said the question was the shortest distance, and that would be the shortest distance. So let's recap, right? So you're trying to find the shortest distance between a vector and a point. I like to draw a little picture here, but it's the direction of the vector I care about. That dotted with the actual point to a point on your line. So you just make a random point on your line, Q, N, whatever you want. Right, and that's just a vector equation. So you find this equation of that line, and you dot that with the direction vector. So all this was about. And you get when you hit that point, when you hit that Q. So then you got to plug it back into your equation. You get this is the point where it actually hits. But what is that magnitude? Because the question was what's the distance? So you plug into the magnitude equation, and you get that. Let's do another one. So map shows distance measured in kilometers. Ship R is moving direction 34 at 10 kilometers per hour. Write an expression for the position of the ship in terms of t, the number of hours after leaving port A. So they want a direction for the position of the ship. So this one, A just wants the normal vector equation. So we know how it starts. A equals A plus TB. We already have our initial point. We're leaving port A, so that's my initial. So that's going to be xy equals negative 8,3. What we do need is our direction. Now, I know most people just probably put 3/4 as our direction vector. That would be okay, but we actually know how the speed it's going, which is 10 kilometers per meter. So we got to figure out what this speed is to make sure it matches 10. Because if this is like only 2, then I got to multiply by 5. Right? If it's only 1, I got to multiply by 10. So you got to make sure the speed matches. So let's find the speed of this guy, of my direction vector. Well, the way you find speed is you take the magnitude of it. So that's 3 squared plus 4 squared. Which we should know is probably just going to be 5. Famous 3, 4, 5 triangle. Those are switched. 3 squared is actually 9, but I knew the answer is going to be. So 5. So magnitude of this guy is 5, but I want a magnitude of 10. So that means I'm going to have to multiply this guy by 2 to make it match. So magnitude is actually going to be 6/8. Right? So that's the equation. It's my initial point, which is A. I'm going in this direction with this direction vector, but that direction only has a magnitude of 5, and I'm going to magnitude of 10, so you're going to multiply by 2. So that's A. Now let's do B. Find the time when the ship is closest to port 10-2. So remember the way we do the exact same problem we did earlier. So the way we do that is we got to find a direction vector here, which we know is 3/4. You could use 6/8, but it's not going to matter because it's parallel. So we're going to get a direction vector 3/4, and we're going to dot it with this point here, PR. That vector equation PR. Let's get 0, right? Because the shortest distance between 2 points is a 0. Now, this time, all we're finding is the time. So the last one we did wanted the actual distance. This one just wants the time when it's shortest. We just got to find t. So it's going to be the direction vector dotted with the vector right there. So that make it a right angle. So let's figure out what PR is. Well, PR is tip minus tail, R minus P. Remember, R is any point on this line. So R is literally just this direction vector right there. This vector right there. That's what R is. It's any point on this line. This is the equation for that. Because again, I don't know where R is happening. So it's this guy. So R is literally just going to be negative 8 plus 6t and 3 plus 8t. That's all R is. You want to think about it this way? R is xy. What's xy? Xy is this whole thing. P, now they actually gave us P, 10-2. So if I simplify this down, I get PR equals negative 18 plus 6t and 1 plus 8t. So that's my PR. And again, I'm going to dot this PR with the direction vector, which is 3, 4. So it'll be 3, 4 dot negative 18 plus 6t for 1 plus at, and that should equal 0. Dot product, you just multiply the corresponding parts. So 3 times negative 18 plus 6t plus 4 times 1 plus at. Distribute. That is negative 54 plus 18t plus 4 plus 32t equals 0. Add up like terms. I get negative 50 plus 50. Yeah. Equals 0. So 50t equals 50. T equals 1. Now in this case, that's all the question was. At what time is it? So is that 1 minute? 1 hour? Kilometers per hour, so 1 hour. So 1 hour, it's closest to port P. Again, if they wanted the distance, I would have to go back, plug it in for PR, and then take the magnitude PR. But in this case, it's lengthfully just one at a time. Okay, let's do one more example. Consider the point -1, 2, 3, and the line with parametric equations x, y, and z given. Find the coordinates of the foot of the perpendicular from P to the line. That's just a fancy way of saying, so how we have our lines here. That's line, that's my parametric equation, so that's this guy. We have this point P out here. We want to find the closest distance, so this right angle right there. That's the foot of it. That's what they're talking about. Find that point. And then B, find the shortest distance from the line, from the point to the line. So again, find the shortest distance. So it's another one where you actually find the distance. So how do we do it? Like we always do, right? Make this point, pick a point there. I don't know, let's call it N this time. And N is just any point on this line. So, well, what is this line? Well, the line is this parametric equation. Let's just rewrite it though. So I rewrite that parametric equation, x, y, z. This point, x, y, z. That's actually not good. That'll be a point x, y, z like this. Okay, so the vector x, y, z is, remember, the first point's your initial position, so that's a constant here. So 1, negative 4, and 3. Plus the direction vector, which would be the ones with the variables. So 2, 3, and 1. So that's what that line is. That's what this line is here. It's going by that direction. Starting at some point 1, negative 4, 3, and it's going in this direction. N is any point on that line. So N is just like combining these. So my N is just a combination of those guys, which is going to be -1 plus 2t, -4 plus 3t, and 3 plus t. So if I want the equation of this vector here, Pn, that's all we're really asking for. What's the equation Pn? Well, Pn would be tip minus tail. So it's me that minus P, which is -1, 2, 3. So I would get, oh wait, that's actually a positive 1. There we go. Yeah, that would have been a mistake. So positive 1's right there. So I'm here, I get 1 minus -1, which is actually a 2 plus 2t. Then I get -4 minus 2 is a -6 plus 3t. And then 3 minus 3 is 0, so just t. So that would be my vector Pn. So it's the answer to A. So there's A. Find the coordinates of the foot, just that. Find the shortest distance. Now remember, to find the shortest distance, first you basically gotta dot the directional vector with my Pn. So I want the dot product of these two guys to be 0. So perpendicular is the shortest distance. So if I take the dot product of the direction with my equation right here, then I'm gonna get the shortest distance. So P dot Pn should equal 0. P is the directional vector, so if you look at the equation here, my direction vector is just 2, 3, 1. And my Pn we just found is 2 plus 2t, -6 plus 3t, and t, and that should equal 0. Remember, dot product, just multiply the corresponding parts. Multiply the x's, multiply the y's, multiply the z's, add them all up. So I'm going to get 2 times 2 plus 2t, plus 3 times -6 plus 3t, plus 1 times t, and all this should equal 0. Distribute. Add up like terms. I get 10 plus I get 14t minus 14 equals 0. Hey, once again, we're going to get 1. I mean, much prefer 1 to like the 2/3 I got the first time. So t is 1. So it happens 1 hour again. Remember, this time that wasn't the question. It doesn't say when does it happen. It says what's the actual shortest distance. So I got to plug this 1 back into my Pn because I'm finding the shortest distance. This is my distance. So what is Pn? Plug in 1, so I get 2 plus 2 times 1, negative 6 plus 3 times 1, and 1. And I get 4, negative 3, and 1. So that's the vector Pn, but again, the question was the shortest distance. So gotta find the magnitude of Pn. So 4 squared plus negative 3 squared plus 1 squared. And I get 6 square root of 16 plus 9 plus 1, which is square root of 26. That's the shortest distance. And that's it.